1.7 absolute value inequalities. This is part 2 where we'll just focus on solving absolute value inequalities. So there's a rule in your book. There's actually 2 rules in your book. So there are 2 possibilities when we look at an absolute value inequality. So the first rule works when we have absolute value greater than a positive number, and the second rule is for absolute value less than a positive number. So if you have the first situation, then you're going to break up your problem into 2 inequalities. So notice what happens. The first we'll call this the first inequality. The first inequality you get is the same as what you have. And the second one, you're going to change the sign, make that negative, and change the inequality. And you're going to connect these 2 with the word or. If you remember, or means union of sets. So for a situation where we have greater than, it's going to be a union or an or. If we have the second situation with a less than, or it could be less than or equal to, it could be equal to for both of them, by the way. Then what we're going to do is the easiest way to break this up is to write it as a double inequality like that. If you want, you can also break it up into 2 separate inequalities and connect them with the word and. And means intersection. But notice that I wrote easier. So this way right here, this is the easiest way to do it. But if you wanted to, you can break them up. You have to put the word and. So there's a big difference between or and. So make sure you know which one is which, because if we write the incorrect word, then our work will be wrong. So we have 2 examples. We'd like to solve, graph the solution set on a number line, write the answer in interval notation. So example A, we have absolute value is less than or equal. So we're going to look at our 2 rules. For less than or equal to, we have to apply rule number 2. So what we do is we're going to rewrite in this form. So you're going to take 5, make that negative, is less than or equal to y minus 4 less than or equal to 5. Just applying rule number 2. You need to make sure you isolate y in the middle like we did earlier. Add 4. Negative 1 is less than or equal to y, less than or equal to 9. This is solved. For these problems, graphing and interval notation are really easy because we always shade between the 2 numbers. And we have to make sure we use a bracket for both negative 1 and 9 since they both have an equal. And interval notation follows negative 1, 9. Next, we have absolute value greater than a positive number. So for greater than, that's going to be rule 1. And you have to write this as 2 separate inequalities. We cannot write it like rule 2. It will not work. It'll be wrong. So 2 separate inequalities, they have to be connected with the word or. Not and, or. So let's see. Let's do this one first. So basically, we're going to take 2x minus 1. Just take off the absolute value. Everything else is the same. Or 2x minus 1. You're going to change the direction of your inequality and make that 2 negative. We solve each one separately. So this tells us that 2x is greater than 3, add 1, add 1, 2x is less than negative 1. We are going to divide by 2 for both of them. X is greater than 3 over 2, or x is less than negative a half. Okay, how do you graph this? Well, here's the number line. Let's start with negative a half. That's the smallest. It says x is less than, so shade to the left with parentheses. We also need to look at 3 over 2. This one tells us that x is greater, so we're going to shade to the right, parentheses as well. So we have our solution, our graph, and then interval notation. Okay, you have to remember that or means union. So to write my answer in interval notation, you're going to write these two intervals separately and connect them with a u for union. So negative infinity to negative a half. Union, use a u, that's the symbol for union. 3 over 2, comma, positive infinity.